How we doing today, everybody? Today I'm going to be giving the answer to one of the most critical aspects of making engine power and engine optimization. You will need to watch this whole video all the way through because the information is spread throughout the entire video. This is the most complete camshaft video on the internet, and if you watch this video all the way through, you will have a foolproof way to select the best camshaft possible without needing to be a professional engine builder and even beating a lot of professional engine builders. Now I'm going to be going over camshaft examples, comparisons, dyno sheets, and I'm going to be giving information that you won't hear anywhere else on the internet. I'm also going to be exposing one of the biggest, most well-known camshaft and performance products manufacturers for their incomplete, grossly overgeneralized theory for making incomplete power with camshafts and how it affects you and how it affects your engine performance and your overall vehicle performance, which means you're probably not getting the most power for your money. Now you're definitely not going to want to miss this. This is going to be a real touchy subject, and I'm probably going to end up wadding some people's panties up, but they'll just have to stay wadded up until they pull their heads out of their arses, because this is physics, and there ain't no denying it. So let's get on with it. So I'm going to be doing this video a little different. Today we're going to be hanging out, and you're going to be my buddy, and we're going to be going on a drive, and I'm going to be sharing some camshaft secrets, camshaft facts, and I'm going to have proof to back up everything I say. I will also be giving information that you literally won't hear anywhere else but here, and from anyone else but me. And if you pay attention to this entire video, I will be handing you the secret to select a camshaft that will produce the best power and torque for any given engine combination. Now let's get this show on the road. If you haven't seen any of my other videos, don't mind the annoying squeaky clutch. There are all kinds of different ways people try to go about building, or more commonly assembling, an engine to try to obtain a specific horsepower or torque goal at a specific RPM. And a lot of times it's all too common for people's main focus to be primarily on an unrealistic horsepower or torque number, and all they want to do is focus on that unrealistic horsepower or torque number without fully understanding how to even go about achieving that specific power number. Now occasionally you'll come across somebody that has more of an understanding of the concept of engine combination selection. Enough understanding to try to hit a specific power number while having the knowledge to at least make as much torque as the engine is capable of, while making the best torque and horsepower curve possible. But actually knowing how to make the proper calculations to spec an engine combination, knowing full and well that you have to give an engine what it wants for valve events, not what you want for valve events, to optimally attain the desired results. In other words, achieve the maximum torque and horsepower numbers with the biggest power and torque curve for any given cubic inch engine combination or any given application, whether it be a purpose-built, no expense spared with all the best parts available, or a budget street engine combination built with the best parts an individual could afford or already has. A properly executed engine combination, even on a budget, can still allow you in some cases to go out and dominate those no expense spared builds, or at least be extremely competitive. Now the ability to complete the task of getting the most power with the biggest torque curve out of any given engine combination or any given application, or achieving a high horsepower engine with the biggest torque curve allowable for the cubic inches, which would equate to optimal performance in a race application. Accomplishing these tasks successfully requires a thorough understanding of the different levels of physics, dynamics of all kinds, the effects and importance of proper valve event timing, and the complex interactions and inner workings of an engine. Now finding somebody who actually retains all this knowledge properly is a rare occurrence, because obtaining this knowledge takes a lot of dedication, time, experience, and research. Now unfortunately there are a lot of guys out there that think just running random people's engine combinations on a dyno is engine research and development. This is not engine research, and it damn sure isn't development, obtaining random data from combinations. Sure, you'll get some info and an idea of what people's random combinations do, but as I said, this is no means engine research and development. These are the same type of individuals that try to tell David Bisart he's wrong. These individuals tend to have an extremely inflated sense of self and are living in the blissful land that is ignorance and narcissism with their narrow minds and lack of education. Now actually coming across an individual without an inflated sense of self that is actually retaining this knowledge correctly is pretty damn rare. But knowing all the proper information comes with the ability to build engines that run at or near optimum capacity that any given engine combination is capable of. with the potential end result being an engine capable of taking first place everywhere it goes, being back-to-back champion of multiple events, or just being a serious contender against larger engines for the top position, unless of course the engine breaks something on the vehicle. Now whether the engine was built for drag racing, high-performance street car, mud racing, truck pulls, circle track, off-road racing, pickup truck, dually, etc., whatever the type of racing or the intended use of the engine, the technology exists these days to build the most effective engine combinations to date. But these days the desire to just get an LS engine from the junkyard and simply put an inoptimal off-the-shelf camshaft in it, slap some turbos or another form of forced induction on it, and call her good. This is the new method for building power. Just crank up the boost to fill the need, which is further just displacing the want or need to learn the knowledge to get the proper understanding of the different levels of physics, dynamics, events, and all the other complex things going on inside an engine, to obtain the ability to know the best way to build an optimal or near optimal engine combination, whether it be naturally aspirated, turbo, blower, nitrous, or a combination of both forced induction and nitrous. If the individual is experienced enough and retains all the proper knowledge, one may easily figure out how to apply the different knowledge and physical principles, dynamics, coefficients, etc. the individual had acquired on the quest for knowledge to build optimal naturally aspirated engines. And if the individual had gained enough knowledge, they should be able to properly calculate the complexities of building engines that are optimally suited for power adder applications and apply them to help them build optimal or close to optimal engines for specific blower, nitrous, and turbo engine applications. Now a lot of this engine combination selection and optimization breaks down to something that sounds as simple as selecting the proper camshaft that correlates with the engine's combination of parts and the intended use. Sounds simple, right? Well, the complete understanding of camshafts has always been a complete mystery to most of the population and a lot of pros, which is understandable because there's a lot of things that are very complex that must be comprehended if you want to be proficient at speccing proper camshafts for optimal or near optimal engine performance. Now a lot of people, as soon as they think they have the concept of camshaft selection figured out, they eventually get smacked in the face with a reality check that they are way off and they need to go back to the drawing board and reanalyze the situation. And of course, in some cases, now I'm not speaking of anybody specific, but there are those who, instead of continuing to seek more knowledge, will continue to go on in the bliss that is ignorance and continue to think that what they know is absolutely correct. Then they will proceed to share their bullshit, and some will take the bullshit as gospel, and the bullshit will propagate, and slowly the bullshit will spread. And ever since the internet, the bullshit's had the ability to spread like wildfire, and it usually does, and it always seems to go mainstream. Then it soon seems like almost everybody else is starting to spread the bullshit and share unrealistic horsepower and torque numbers that further inflate the ignorance of what engines are capable of. Here's an example of the type of ignorance at play here. This ignorance allows for certain individuals to have the confidence to think that they know everything, when in actuality they have no idea and don't even realize that they don't even know what they really don't know, if you know what I mean. But when those individuals are in the front of the right people that have obtained the proper knowledge, the individual who has unknowingly tried to spread his bullshit to the individuals who retain the certain correct knowledge, the said individual spreading the bullshit will have clearly exposed themselves and their blissful life of ignorance. So the owners with the bullshit will proceed to try to tell you incorrect information about things that they think you don't know anything about, when in reality, as I said, they don't even know what they really don't know. Now the results of all this BS and misinformation being spread over the years is that there has been and always will continue to be all kinds of different bogus theories, formulas, and equations that people try to use to select camshafts. Some of these theories are complete BS. Other theories are pretty far from ideal. Some theories will produce what I would call decent power, and there are a few other theories that produce on the verge of what I would call impressive results. But what specifically about an engine do you have to focus on? What are the proper calculations to choose a camshaft that will produce near optimal or optimal engine performance? Now to start with, I don't want to go as far to say any of these incomplete, not very well thought out ways to choose camshafts that produce less than very impressive results are absolutely wrong. But if something isn't at least truly impressive, or better yet optimal, why recognize it? It's like giving a participation trophy for creating an incorrect camshaft and for having a negative effect on engine performance, when it should have initially been acknowledged for nothing but what it truly is in the first place, which would be incorrect. In the sense that being is the goal with camshaft selection is you're trying to get all the power you can for your engine combination for your dollar, and or optimize a specific engine combination for maximum output. Now, had these subpar theories and formulas had never been acknowledged, never been given their participation trophy, and had instead been labeled as BS or snuffed out completely, you would clearly be able to see through whatever BS was trying to be fed to you. Because without the participation trophy, you could clearly see that it isn't worth a shit if the goal is try to make the best power, win races, win legitimate first place trophies, or even be successful at all for that matter. Alright, we're going to start by acknowledging the most widely known, most common way people choose a camshaft, and this is by duration. Now, I'm not saying this is an absolute horrible way to choose a cam, but trying to optimally select a camshaft primarily by duration and achieve impressive results, or better yet optimal results, takes a bit of complex calculating and years of experience. Now, before we go any farther, before I lose anybody who may be thinking, well, why in the hell should I listen to what this guy's saying about camshafts and engine? And who the hell does he think he is? He don't look like no damn professional. He's probably just talking out of his ass. I mean, this is YouTube. If he's so good, why doesn't he have his own shop? Or why isn't he a professional engine builder? Or why haven't I ever heard of him? Or why isn't he still racing? Well, sometimes people are dealt rare circumstances in life and they get tested. You just get dealt a shitty hand and you miss out on opportunities in life. The answer to that last question is a long story, but I'll keep it fairly short. When I was 20 years old, I had gotten pretty sick and it left me covered in scars. I had to take an oral chemotherapy drug for 9 months that ended up weakening my spine that was already in bad shape. Well, one day at work, we were unloading a 250-pound pneumatic missile, and one of the guys handing it down had lost his end. It dropped from about 3 feet and I ended up catching it. It had resulted in a multi-level compression fracture that shot disc material up into my vertebrae. Now, after I had broke my back, I dealt with L&I for years, and ultimately it ended up getting screwed over by L&I in the end for my $115,000 settlement for my back being messed up. I had tried for a few years after that to keep racing, but physically I couldn't do it, and financially I couldn't do it. Mud racing is extremely physically and financially demanding. It takes a special breed of person to mud race and be successful at it. It takes a lot of dedication, cleaning, and maintenance. One of the most physically demanding aspects of it is having to change 47-inch tires by myself that weigh 200 pounds mounted, and I always did it purely by brute force. Then, 2014, I was paralyzed while working in the garage, and that'll tend to slow you down a bit. You just having to learn to walk again, and having to learn to use your arm again. And now, coming out of that situation, I ended up with a living hell of a condition called CRPS. I fought like hell to get back some normalcy, but over time, my brain and body is just getting worse. Now I'm slowly declining. Alright, now that I've cleared that up, any reason for anybody to give me BS about my current status or lack of status? Because believe me, my current physical state and current physical abilities do not do any justice to the representation of who I am. Alright, now I'm going to get to some reasons why you may want to stick around and listen to what I have to say. Now I'm going to start here with a little bit of history about me. Now I'm going to start by acknowledging the fact that I'm not saying that I know everything. I absolutely don't, and who in the hell does? But I try to learn more every day, and I most definitely have more knowledge in this area and a far deeper understanding of this stuff than 98 to 99% of the people walking this earth, and that's not an exaggeration. Anyone who knows me knows that I won't talk about anything specific or give my opinion or advice on something unless I know absolutely sure I know what I'm talking about. Now, up until a while ago, I would have never even thought about giving away any of this valuable information I've acquired over my lifetime, but I'm not really in the position to utilize my knowledge to the fullest extent anymore, because since being paralyzed, it has resulted in a rare condition called CRPS, which is the most painful condition known to modern medicine. In extremely rare cases, like mine, it will affect your brain like dementia, and slowly over the last 8 years it's been affecting my brain. But over the last year and a half, it's been affecting my brain faster. And just over the last year, it seemed to have sped up the process. And now over the last 6 months, CRPS is really affecting my brain, and I'm starting to lose my ability to think, hold on to my thoughts, my ability to communicate, articulate my words, and eventually I may lose my ability to function and process information. CRPS is rapidly causing me to lose my memory, myself, and eventually I won't remember anything anymore. And I have no children to pass on any of my knowledge, so this is all part of the reason why I had started this channel in the first place. I had intended to share as much of my knowledge as I could with anybody who wants to build more power, go faster, or anybody who just wants to listen and soak up what I have to share while I still remember it. Now there's no way I'll be able to go over everything I know. We would be here talking for literally years. I've got a lifetime, or at least my lifetime of personal experience, which is out of my 36 plus years on this earth has equated to 26 plus years worth of everything from race winning engine building, engine combination development, engine modification, engine optimization, drivetrain optimization, engine research, mental data points from dyno run sheets, data points from all aspects of certain engines, years of studying camshafts and the polynomials and coefficients of camshaft lobe design, valve events, all kinds of different levels of physics, etc. I've had a fascination with this stuff my whole life. Starting at around 8 years old or sometime there before, I started being taught by my grandfather, who was a physics engineer for GM, specifically Chevy and Pontiac, and later built race engines, and eventually ended up back at Pontiac, who he retired from. He had also known Smokey Unick at one point. And of course, my dad had learned from my grandfather, and I had learned primarily from my dad, who was a highly respected engine builder and machinist, and was an expert in so many other subjects. He may have also damn near been a genius. My dad had learned a lot from my grandfather and then expanded on the knowledge. He had passed some to me, and I had continued to strive for knowledge my whole life. So at about 8 years old, they had started teaching me the physics, dynamics, events, etc. of an engine, explained to me what everything was, what it does, why making certain changes did certain things, and then when and why to make those certain changes to achieve specific results, and so on. So by the time I was 10 years old, I probably knew more about engines, cylinder heads, and camshafts than most grown men. When I was 10 years old, my dad had actually started me working in the machine shop. I started cleaning stuff, and then I eventually started doing cylinder heads, building engines, operating machining equipment, and playing on a flow bench. I had personally built and had been a part of many successful, high-end, naturally aspirated engine builds, nitrous engines, blower engines, and turbo engines. Now here are a few more examples of my experience that solidify my knowledge and why you may want to hear what I have to say. So shortly after I had started this channel, I had made a video on one of my engines that I'm going to talk about here in a minute. The video was called How to Build a 550 to 600 horsepower race-winning small block Chevy on a Budget. Well, Mr. David Bisart had seen that video, and he had decided to send me a message complimenting on me on the engine, and he had said that he was very pleased to see what he had called my intelligent, well-educated choice in optimal camshaft specs, especially the LSA. He had also complimented me on the extra info I had put in the comment section and the answer I had given to people's questions in the comment section. He had said that everything I said can be solidified and confirmed in a few of his videos, one of the videos being about how the cam companies still can't get their camshaft selections right, and the other one being about a highly competitive budget 383 build that made 620 horsepower and 545 pound-feet of torque. He had put his 383 video out literally one day after I put my video out. He later went on to recommend my channel to his subscribers. He told the subscribers that Adam and the guys over at the Cattle Dog Garage are running a very good program and giving quality information. Little did he know at the time, I'm the only one running this program and providing all the information. So now that I've given you guys a little bit of information about my past experience and that I have been unintentionally recognized by David Bisart, received compliments from him, and have been recommended to people by the man himself, which I would say is an accomplishment in itself. Now I'm going to briefly explain who David Bisart is for those of you who are thinking to yourself, well, who is David Bisart? I'm going to give a tiny explanation about the man. So David Bisart is an engineer with 60 plus years of experience in the high performance engine and racing industry. He has worked with literally the best in the business, He is advised for the best people and companies in the business, and he is highly respected by all the best in the business. He has written at least 30 highly respected engine building books. He has also written over 4,000 magazine articles. He has over 40 automotive patents and he's even developed cylinder heads for Formula One. He has won multiple championships in different styles of racing. He has thousands upon thousands upon thousands of dyno pulls from his many years of engine research and development. Now, what I've said about David is only a small fraction of what he's done for the automotive and high-performance world. You could write multiple books about Mr. Bisart's accomplishments alone. I can legitimately say that David Bisart is a damn genius, and I don't give that classification loosely. If David Bisart sees something mediocre, he won't acknowledge it. And had I been feeding people BS, he probably would have told people, "Hey, don't listen to this guy because he's full of shit." He has no problem exposing the spreading of BS related to engine performance. Because like me, Mr. Bisart is passionate about proper and optimal engine performance. Now, if being recognized by David Bisart, complimented by, and recommended by him don't account for something, I don't know what does. I'd say just that right there should help you at least have a little faith in what I'm saying. And if you continue to listen to what I have to say, it will definitely solidify in your mind multiple reasons for you to believe what I'm saying. You can at least listen to the knowledge I carry and potentially expand your mind and maybe reconsider your thought process, because this is probably going to be a whole new way to think and look at things. Now, being as David Bisart is at the highest level of knowledge looking down at me, I would say he would be about the ultimate judge of one's knowledge in this arena, especially knowledge pertaining to engines, performance, camshafts and cylinder heads and valve events. As I said, with David Bisart being at the highest level of knowledge, he could tell that I was not the typical self-proclaimed know-it-all, spilling shit out the side of my neck. Now, most of my experience was primarily obtained through studying small block Chevys and big block Chevys. Most of my physical experiences with small block Chevys, but I've built imported cylinder heads for, of course, small block Chevys, big block Chevys, LS, small block Ford, big block Ford, Ford FE, and a couple different Mopars and Toyota 22Rs and a bunch of others I can't think of right off a hand. Now, this knowledge I'm about to lay down relates to any conventional V8 with a 2-valve cylinder head. It works for inline valve, canted valve, and Hemi heads, but you have to know how to make the proper calculations and adjustments, and that's dependent upon the combination. But the physics, dynamics, events of all the interactions translate right across the board to all the other engines as far as optimal ways of creating performance. Now, personally, I prefer small block Chevys. I have Chevy orange running through my veins, and I was born to live the small block Chevy life, and I will live it till I die. Now, here's a prime example of my knowledge I'm giving today, and another nugget of some of my experience. Now, this is the engine that got Mr. Bisart's attention. When I was 20 years old back in 2006, with very limited parts, I had spec'd and built my personal most successful small block Chevy for my mud bog / drag truck. Now, keep in mind, back in 2006, a 383 pumping a legitimate 580 horsepower and 545 pound-feet of torque naturally aspirated, which is 1.51 horsepower per cubic inch and 1.42 pound-feet per cubic inch. Now, that's a lot of power, especially from a stock iron-headed 383. Hell, even today, a stock-headed naturally aspirated 383 LS engine making 1.51 horsepower per cubic inch and 1.42 pound-feet per cubic inch would be pretty impressive. Hitting those power marks, specifically the pound-feet per cubic inch, these numbers are achieved by the top 1 to 2% of engine builders, and I did so with heavily ported and modified stock iron heads. So back in 2006, when I had built this engine, it was for an 84 Chevy K20. The 383 was intended to spin 47-inch tires. The engine has 12.96 to 1 compression, and it's making 580 horsepower at 6,500 RPMs and 545 pound-feet at 5,200 RPMs. And on what they call a supposed 200 shot of nitrous, it makes about 750 to 800 horsepower. Now, naturally aspirated, the 383 happily sings the music of my people all the way up to 7,500 RPMs. It will actually sing the music of my people all the way to 78, but I keep it chipped at 75. It has a heavily ported Performer RPM air gap, and the heads are just a set of heavily ported and modified 186 camel hump heads, which are just old stock iron heads from the late 60s and early 70s for those of you who don't know. The camshaft specs out as a 108 LSA, 104 degree intake center line, 620 thousandths lift. It's a 661 thousandths lift with the 1.6 rocker. It's 248 degrees of duration at 50 thousandths. This engine makes the power it does because every single little detail that was taken into account that ultimately led to the optimization of the engine with the parts that were available. This little 383 won every big event we ever went to except for one. The 383 was a 3-time back-to-back champion and a 1-time third place winner at the largest mud racing event in the Pacific Northwest, which would be Washington, Oregon, and Idaho. There was 150 to 200 trucks, with 40 to 50 trucks per class competing for the best time or distance. Now, being as the stock iron 186 camel hump heads on this 383 are the limiting factor of the engine. If I would have just had the money to buy a nice set of AFR or Brodix 220cc aluminum heads, which I would have of course ported, I could have easily made, just from the cylinder head change, 600 to 620 plus horsepower. Now, if I had replaced the ported RPM air gap to a nice ported single plane manifold, changed the 850 carb to a 950 to 1050 carb, and then spec'd a different camshaft that I had optimized to the new cylinder head and manifold carb combination, I could have easily built an engine that made anywhere between 650 to 720 plus horsepower naturally aspirated with a solid torque curve. Now, if I had had even more money, I would have spec'd out another camshaft that I had optimally selected for a different application. And then I could have easily set up this 383 to make 1500 plus horsepower with turbos or on nitrous. Now, since I just mentioned turbos, I'm going to touch on the subject of cams for turbo engines and a little bit of turbo selection. Now, if you plan on speccing turbos for your engine, I recommend learning how to analyze compressor maps. Compressor maps will display the corrected mass flow rate and the efficiency, which will allow you to determine the horsepower potential of a specific compressor stage. Now, this data is important because it gives you the power capability that a turbo can support at any given pressure ratio and mass flow rate. Compressor maps will give you the representation of speed, efficiency, pressure ratio, and mass flow. This will aid you in the selection of the correct one for the specific application. One of the most important aspects of building a turbo engine, next to the proper valve events, is compression ratio and taking into consideration all the different pressure ratios. The engine is of course consuming boost being created by the exhaust back pressure. Now, this is a pretty complex calculation that I'm not going to go over now, but the pressure ratio between the intake and the exhaust is one of the biggest factors in determining the optimal camshaft for a specific turbo engine combination. The end result of not having to produce more boost to make an equivalent power production is an engine that will make more power while being under less stress at any given power number because it's not fighting itself, which will in turn allow for an increase in power handling capabilities of the engine and allow more power to be produced with less stress on said engine, and ultimately increasing the durability and longevity of any engine. Now, when you think like me, you notice things, and I've come to notice over the last 20 years or so that the most common way to, well, I'm not going to say this is a way to build an engine, more like reassemble it. Anyway, the most common way to build horsepower in general anymore is a turbo engine. More specifically, get an LS from the junkyard, tear it apart, gap the rings, maybe put new bearings in it, put an incorrect off-the-shelf turbo camshaft in it, slap some turbos on that baby, throw a tune on it, and voila, that's the modern day what people call engine build. Or there's those who will build turbo engines with a bunch of random good parts that they may think are right, but all of them don't correlate very well, and by no means have the proper valve events, with the results being an engine that may make power, but you have to put more boost to said engine to make equivalent power, as if the engine would have the proper combination of valve events that correlate with all the pressure ratios and all the other necessary influential factors of the said engine, with the results being an engine that with equal or higher power output figure than if the engine had the engine with the boost turned up. And the engine with the boost cranked up will also be under a lot more stress, and this stress is effectively reducing the efficiency to produce power and the power handling capabilities, which will have a big effect on the durability and the longevity of the engine. Alright, so now that I've given a little knowledge, engine detail, and a little info about myself, so you can understand why you might want to listen to me or believe what I'm saying. That little info I've given is obviously nowhere near the end of my experience, but it's the end of me wasting time about talking about myself. Now by this time, at least some of you should have an understanding of where I'm coming from. Now we're going to get to the good stuff. Now most individuals try to choose a camshaft by the use of duration numbers to dictate the RPM at which peak torque and power occur, and usually get stuck with whatever lobe separation angle, intake center line, and lift the cam companies have given that specific camshaft. Most individuals, after selecting their target set duration and lift numbers, are done with the selection of their camshaft without even acknowledging the lobe separation angle, and the fact that neglecting the lobe separation angle can make an engine that has nice cylinder heads and everything that go along with it. The only thing is wrong is the LSA is nowhere even close. The result will always end up being rather disappointing, especially if you were expecting at least decent performance. Although some might not end up disappointed because they may not know any better, being that they probably never truly experienced a properly built combination and how a properly built engine should feel and really perform. Now when you choose an off-the-shelf camshaft, you can't expect to optimize any specific engine combination. The optimization of a properly built and executed engine combination, when it comes to camshaft selection, should start with lobe separation angle, which is something that to most people is a complete mystery, and the ability to know how to properly calculate lobe separation angle is unfathomable to most. The concept that there even exists such a thing as a perfect lobe separation angle is actually so complex and complicated that to a lot of the so-called professionals in the camshaft industry, they don't even comprehend it. So they create their own incomplete, overgeneralized theories and equations and formulas to come up with what they think or what they want to be the key to producing power. But in actuality, the equations and formulas some of them are using or creating throw away the most important aspect of the camshaft, being lobe separation angle. Their theories and equations do not produce the proper valve events that will equate to the proper power production that could have otherwise been produced had the camshaft been properly spec'd, starting with lobe separation angle. Using the proper calculations and considerations, the correct lobe separation angle is calculated and influenced by many different factors, such as cubic inches, cylinder head characteristics like intake valve diameter, port energy or velocity, low lift flow, how fast or slow low lift flow will be presented to the cylinder, rocker arm ratio, valve job, valve seat angle, intake to exhaust flow ratio, valve throat diameters, valve curtain area, discharge coefficients, compression ratio, piston dwell points, rod length, piston speed, overlap triangle, etc. It also obviously requires a lot of complex calculations, complex variables, a deep understanding of engines, and the knowledge to make the proper calculations to determine the right lobe separation angle for optimal engine performance. Now even when lobe separation angle and all the other specs of an engine aren't optimal for a specific combination, lobe separation angle will still ultimately determine what RPM peak power and torque are produced, and will also dictate how much power and torque are produced across the curve, whether it be higher or lower on the RPM range. For example, if you take 3 different camshafts with identical specs other than lobe separation angle, you will get 3 different power curves, and if you're lucky, you may hit the golden ticket as far as the right LSA, or come close to the right lobe separation angle, which will produce higher peak power and torque with the best torque curve and power curve. I had gone online and I had got lucky enough to come across this article that Richard Holdner had written. It's a comparison he did with 3 different camshafts ground on 3 different lobe separation angles. This test was made using a 402 cubic inch LS2 LS3 hybrid engine. All 3 camshafts had identical specs except for lobe separation angle. Lift was 624 thousandths, with a split duration of 232, 242 at 50 thousandths. They were ground on a 120, 112, and 108 LSA. The 120 LSA cam produced 570 horsepower at 6,200 RPMs and 535 pound-feet at 5,200 RPMs. He had also taken a measurement at 4,000 RPMs, was 484 pound-feet. Now the next one is the 112. The 112 had lost peak power and gained torque, which is typical to be expected of the 112. It had produced 567 horsepower at 6,200 RPMs and 544 pound-feet at 5,200 RPMs. The steady state measurement at 4,000 measured 522 foot-pounds. Now notice how the 112 does the typical changes you would expect from that change. Horsepower is down some, but it stayed at the same RPM. And torque is up, but at the same RPM. Now I'm going to tell you something that you won't hear anywhere else but here. Notice how the 120 and the 112 in the upper RPM, the 402 LS is almost insensitive to change from the 112 to the 120, which is evident being that the peak RPM at which peak power occurred didn't change. This is because the valve timing events from the 112 to the 120 are already way too wide for the engine's cubic inch to allow the cylinder head to properly fill and evacuate the cylinder at the right times to be able to increase the RPM at which peak power occurs. Simply put, in other words, the cubic inches of the cylinder and the cylinder head's flow characteristics and other aspects don't match the valve events caused by the wider lobe separation angle. Therefore, the 402 cubic inch LS can't utilize the effects produced by either the 112 or the 120, both of which prefer to produce power at a way higher RPM. Now, the 108 LSA didn't produce the typical results you would expect from a lobe separation angle change. We'll get to the results of the 108 in a minute. I'm going to use the results from the 108 LSA to prove a point that will start to solidify in your mind some belief that what I'm saying is correct. Now, I've already started explaining why, so I'm going to use this piece of evidence that contradicts an incomplete, overgeneralized theory for camshaft development from one of the most popular camshaft and performance part manufacturers, who I'm not going to name, but I will refer to the perpetrator this one time as BT. You may figure it out. Now, from here on out, I will refer to him as Mr. T or T. Anyway, this specific culprit believes that the proper way to build power is a bogus camshaft theory in which he insists lobe separation angle means nothing. Mr. T thinks LSA is simply just a derivative of intake centerline, exhaust centerline divided by 2 will give you lobe separation angle, and that there are no other influential factors when it comes to lobe separation angle. Now I'm going to point out something. I'm going to start by saying it's not that I don't understand the concept of putting the valve events where you think they might need to be and letting the LSA fall where it lands. It's definitely not that I don't understand. It's because I absolutely do understand. I completely understand this concept, and I know it's incorrect. Specifically, if you're looking for impressive crease in power. There are so many influential factors that need to be accounted for. It's not a matter of putting the valve events where you think they need to be. It's a matter of timing the valve events where the engine wants the valve events to be, based primarily on bore, stroke, cylinder head flow characteristics, primarily low lift flow, valve diameter, valve throat diameters, discharge coefficients, port velocity or energy, valve curtain area, rocker ratio, compression ratio, rod length, piston speed, intake to exhaust port flow percentages, etc. There's a correct way to simplify all this a little bit so you can figure it out. Now, all these things having an influential factor just on determining precisely how to calculate the lobe separation angle alone. And then you have Mr. T saying that LSA is simply just a derivative and not an input, and that nothing physically has an influence on the selection of the correct lobe separation angle. Mr. T says there's no positive effects to the optimal lobe separation angle because it doesn't exist. Now, this is the kind of simple, incomplete, generalized conclusion you come to when the correct research hasn't been executed, resulting in the simplest explanation of lobe separation possible. You can't expect to fully comprehend the true concept of lobe separation angle and how it's calculated, the influential factors, and ultimately what dictates the selection of lobe separation angle. Now the equation of intake centerline, exhaust centerline divided by 2 equals lobe separation angle. This is actually just the distance of the angular measurement between the lobe centers. This is about the absolute worst way to select a lobe separation of a camshaft. There are plenty of dyno sheets out there that would concur with what I'm saying. Now using this theory is like playing calculated roulette with your valve timing events. You're almost guaranteed to get the wrong valve events because it's not based on an exact science within a legit empirical equation that points you in the right direction for a starting point for the proper lobe separation angle, which can be further refined based on influential factors of said engine components as I described a minute ago. This formula is based in reality being the relative laws that regulate everything around us, meaning physics. And this is relating to the dynamics of the engine. Now, lobe separation angle is not a derivative, it is an input. Mr. T claims that you're absolutely not supposed to focus on the selection of lobe separation angle. He believes the way to make more power with a camshaft is to, of course, add intake duration, but to instead change the exhaust opening point to a later point, which is increasing the exhaust duration. Now, this does result in more work done, which equals more horsepower. But one of the downsides to the exhaust opening point later comes with pumping losses. Now this is Mr. T's method to increase horsepower in his different stages of LS camshafts. Now for example, I think this stage camshaft stuff, it makes it easier for people that don't want to think. But personally, I can't stand it, and I think it's just another way to dumb things down. So we're going to start here with Mr. T's stage 3 camshaft. Now they leave the intake duration set at 233 degrees at 50 thousandths, and they leave the exhaust duration at 246 at 50 thousandths. Now this results in an intake valve opening point of 59 degrees, exhaust valve closing point at 7 degrees, intake valve open at 8.5, intake valve close at 44.5. Now this equals a lobe separation angle of 133 plus 3 degrees advance. Now the exhaust duration split on this cam between the intake and the exhaust was 13 degrees wider. And that is how he makes his horsepower. So now we're going to go to the stage 4 cam. So they left the intake degrees, or the intake duration set at 233 degrees at 50 thousandths, with an exhaust duration of 250 degrees at 50 thousandths, which equals an intake valve opening point of 63 degrees, intake valve closing point of 59, intake valve opening point of 8.5, and an intake valve closing point of 44.5. Now this equals a lobe separation angle of 112 plus 4 degrees advance. Now the split between the intake and exhaust duration was 17 degrees. So this means he adds 4 degrees of exhaust duration for every step up in cam stages. Now so in turn, because of the way Mr. T's formula works, every 4 degrees more exhaust duration added ends up widening the lobe separation angle for that specific camshaft 1 degree. Now in other words, as I said before, Mr. T believes that LSA is adjusted according simply by the intake center line plus the exhaust center line divided by 2. And that is how he calculates lobe separation angle. Now here's another example of one of Mr. T's camshafts. Now these are specs from what I will call the Ruck Oris camshaft, because I'm not going to say it directly. Now this is one of Mr. T's most obvious examples that shows his theory on long exhaust duration and the crutch, key, to making incomplete horsepower curve. Now here are BT's claim specs for the Ruck Oris camshaft. It's 216 degrees intake with 220 or 22x at 50 thousandths because he's trying to keep his exhaust duration secret. Now he claims that the lobe separation angle on that camshaft is 107 degrees. Now I'm going to give you the actual specs of the Ruck Oris camshaft. These specs came straight from a cam doctor, so it tells the actual truth. Now the specs on the Ruck Oris camshaft are actually 216 degrees duration on the intake, and his secret exhaust duration on that camshaft is 227 degrees at 50 thousandths. Now the lobe separation angle on that camshaft is not 107 degrees. It's 109. Now, I don't know what's up with Mr. T, claiming that the lobe separation angle is something that it's not, and Xing out the last number on the exhaust duration. I'm pretty sure he did this to hide his prime example and his key to making horsepower with a shorter intake duration. It really shows the theory in play when paired with the short intake duration on the Ruck Oris cam, how he increased the exhaust duration 11 degrees, because as you know, this is his incomplete way to increase the power generating capabilities of a camshaft. Starting with finding the right lobe separation angle in the first place would have resulted in a way more powerful camshaft, and definitely a way more powerful truck camshaft with a way better curve. Now, all the exhaust duration in the world cannot compensate for starting out with the wrong lobe separation angle for a specific combination. In actuality, more exhaust duration can just create more problems. More exhaust duration is typically used by cam companies to overcome low-flowing exhaust ports or restrictive exhaust systems. Now, also adding a long duration of 10 to 15 degrees over the intake, though not the best way to build power, in a lot of cases will allow the engine to carry horsepower past peak for longer without falling off. Now, this would only be beneficial in some forms of racing. Now, I'm not doing this to ridicule Mr. T. I'm just pointing this out as an example to show everyone that just because somebody's labeled a professional in the industry does not necessarily mean that they obtain the proper knowledge to completely grasp the complexities and the number of variables that exist just in the proper lobe separation angle alone. These professionals are considered professionals because at some point in time they had an opportunity that most will never have to be in the position they are in, and they had the financial means to take advantage of the position they were in and start a company. Now, I'm sure there are a few people out there who are not considered so-called professionals, but given the opportunity, would produce a far superior performance product. Now, a lot of these so-called professionals out there haven't accumulated the proper research and executed the proper research on valve event timing and the effects of building an engine starting with the optimal lobe separation angle. The easiest way to begin selecting the optimal lobe separation angle starts with a formula for producing a starting point, and then is further influenced by said engine's physical characteristics, dynamics, coefficients, etc. Now, just because these professionals use a generalized formula that may add up numerically, it does not mean that it applies to all aspects of a specific engine combination. And if it is applied, it will not produce anywhere near optimal results. Just because a formula an individual has chosen to use is different, or even the same as other individuals use to try to accomplish the execution of the proper camshaft selection, don't always make the formulas right. As in Mr. T's case, we're definitely not going to be seeing the best power curves from these camshafts that would have otherwise been possible with a different thought process and a different camshaft formula that accounted for all the other physical aspects of the engine. Now, as I said, I'm not here to ridicule Mr. T. I'm just bringing this into light because I had happened to see one of Mr. T's videos the other day about lobe separation angle, and I could not believe what was coming out of his mouth, because these words were coming out of the mouths of one of the supposed best and most respected LS parts producers and camshaft designers in the industry. Now, I don't have any professional credentials as far as producing a performance product in the automotive industry, but knowing what I do from 26 years of experience in research and etc., I automatically understood Mr. T's theory 100%, and I could immediately see how this theory played out and just how generalized and incomplete this theory was. I was dumbfounded by how generalized and simple it was, and how it's such an incorrect answer to designing a proper camshaft that will generate proper power curve with a solid power production. Mr. T's theory gives absolutely no credit to lobe separation angle, and no other considerations are given to the actual purpose and effective increase in performance that can be had with the correct lobe separation angle. Because believe it or not, as I said, as sad as this sounds, even a lot of the so-called professionals in the cam industry still can't wrap their heads around the effect of lobe separation angle, and can't get an understanding of how to unlock the potential of lobe separation angle by taking the time to learn how to properly select it Most don't fully understand LSA because it actually is rather complex, and it would require a lot of these professionals too many years of specialized engine optimization research, solid understanding of the levels of physics, proper data acquisition, and physical research by putting it all into practice. But ideally, for one to come to the proper conclusion for the correct LSA selection, you would ultimately have to execute the research properly for it to lead you in the right direction. And according to Mr. T's incomplete, extremely generalized theory of LSA, simply just being a derivative of intake centerline plus exhaust centerline divided by 2, and that is LSA. If Mr. T had came to the conclusion that LSA means nothing, I'd say his research didn't take him in the right direction. Now I'm going to show you guys a proper empirical equation that is 100% correct. It is David Bisart's LSA and duration formulas. Mr. Bisart has a hell of a lot more experience than Mr. T. Mr. Bisart's formulas are empirical equations, which means they are based on reality, which means physics, multiple types of research and data acquisition. Being as they are based off of physics means empirical equations are proven to work. The formulas calculate the starting point for the optimal lobe separation angle and one for duration. All these formulas fall in line with the general principles I had learned starting from about 8 years old from two damn near geniuses. I grew up seeing and producing the confirmation of the effects of this theory and the results that this theory produces. I had proven myself with my own personal example that this method is extremely successful and absolutely correct by way of building that 383. That 383 was built not with this formula, but as I said, all the methods I had learned when I was growing up line up with that formula and the way you adjust it accordingly, and the cam specs in that engine show it. Now keep in mind that 383 was the only small block in a class run by 40 or 50 big block trucks. Now my success ultimately did come down to this engine, because no matter how well that truck was set up, it wouldn't have done what it did by winning every time. It wouldn't have spun the tires like it had without that engine. Now, the way I had learned all this stuff was more complex because we didn't use a specific formula. It was all based on knowledge my grandfather had accumulated, being a physicist and engineer, building race engines. Then my dad was growing up, my grandpa and my dad worked on it together. Then my dad later continued to refine it to what it is. I've been doing this so long that I have a lot of this complex info programmed into my brain. Now, because of the way I learned, there is no easy way for me to explain this concept. So I'm going to show David Bisart's formula because it's the easiest way for me to give y'all a starting point for the information I'm about to give. Alright guys, now we're going to start with David Bisart's LSA formula. Now there are guys out there that seem to have a problem with this formula, but those are usually people that don't understand it, or people like we talked about earlier. And then second, I'm going to give David Bisart's duration formula also. Now the lobe separation angle formula starts with a 128, and this works for 10 to 1 or 10.5 to 1 compression, small block Chevys, small block Mopars, big block Mopars. And believe it or not, no matter what anybody tells you, this will work for LS engines also, and I'm going to prove that later in this video. I'm also going to prove that this formula is 100% correct too. Now for Windsor Fords and Ford FEs, you use a 127 in place of the 128. Big block Chevys, big block Fords, and Cleveland Fords will use a 132. So for example, the LSA formula is 128 minus the cubic inches divided by 8 divided by the valve diameter divided by 0.91, and that will give you your lobe separation angle. So for example, 128 minus 383 divided by 8 divided by 202 divided by 0.91 equals 106. Now this is how you calculate the ideal starting point for lobe separation angle. Now the duration formula is going to be lobe separation angle times 2 plus your overlap, and that'll be your duration. So for example, 108 times 2 equals 216 plus say 4 degrees overlap, and that'll give you a 220 degree diversion at 50,000 108 LSA. Now this would be about a perfect cam for a 355. Now if somebody was decent at building engines, they could build a 355 that made around 450 horsepower and still made more torque than horsepower. And as I said, if somebody was fairly decent at engines, they could probably make 465 pound-feet, which is 1.30 pound-feet per cubic inch. Right now all we need to do is figure out how much overlap is needed for the application. Now I'm going to show you guys a simple way to get yourself in the ballpark for the correct amount of overlap for the target RPM range of the said engine. So I'm going to use the 355 for an example still. And I'm going to be stealing the cam numbers off the CompCam 270H Magnum. It specs out at a 110 lobe separation angle, 224 degrees at 50 thousandths, 470 lift, which is irrelevant. Now this cam has 4 degrees overlap, and the RPM range on this cam is 1800 to 5800. Now this is all good and well, but this is on the wrong lobe separation angle for a 355. Now what do? Do you just grind the cam on a 108 and call it a day? Well, this is where most people go wrong. Just grind the cam on a 108 LSA would equal us having more duration now, and would have that 4 degrees more duration would ultimately add 4 degrees more overlap, which would equate to us having 8 degrees of overlap now, which would cause a lower idle vacuum. It would make the engine idle rougher, and it would make power at a little higher RPM. Now how do we accomplish this dilemma? Well, this is where what I call the manipulation of the duration formula comes in. Now we have identified a known camshaft with an RPM range that is good for our specific application, that cam being a Comp 270H Magnum, but it's on the wrong lobe separation angle. So then you need to calculate the overlap, which is the exhaust closing point plus the intake closing point, which will equal your overlap, which in this case is 4 degrees. So the easiest way to calculate your overlap is use the calculator at wallaceracing.com so you can calculate the proper overlap. Alright, so we're going to reduce the duration on that camshaft 4 degrees, which will lower our overlap 4 degrees. So then that'll give us a 108 LSA with 220 degrees duration with 470 lift, which is irrelevant. And that equals our 4 degrees overlap again, as I said. Now this camshaft will effectively give us the 1800 to 5800 RPM range of the Comp Magnum 270, but with a much fatter power curve and more peak power and torque. Alright, now that I've given you guys a way to figure out the overlap for the target RPM range of whatever combination you're building, and given you guys an idea how to adjust the duration for the camshaft accordingly, we're going to move on to more information and a bunch of factual stuff that you guys are definitely not going to want to miss. But before we get started with that, I'm going to show you guys an equation that I came up with that lines up with David Bisart's formula, but it only lines up with 383 cubic inch specific, which is weird because both my engines are 383s. So the equation is 383 divided by 8 times 202 divided by 0.91, and that equals 106. Now just because the formula I randomly came up with adds up numerically and actually is the ideal lobe separation angle starting point for a 383, and it lines up with Mr. Bisart's formula, it does not mean that it'll work across the board for selecting the ideal starting point. Now this is just an example that because an equation is created, equates to a sum that may or may not end up being applicable to one specific combination does not mean the formula will produce the best results. Now for example, Mr. T theory, that intake center line plus exhaust center line divided by 2 equals lobe separation angle. Now as I said before, this is just the angular measurement between the two lobe centers. Now as I had said before, Mr. BT claims that lobe separation angle means absolutely nothing and that you're not supposed to focus on LSA. BT believes after selecting the open and closing points, this will result in your lobe separation angle, which is, by the way, not what an engine wants. It's what Mr. T thinks an engine wants. Now in Mr. T's theory, which he says LSA is irrelevant, his method increasing power above 3500 RPMs only, mind you, is by way of increasing exhaust duration, which Mr. T claims is what an engine actually wants. is more exhaust duration is the key to making power, he says. Now I'd say his research didn't take him in the right direction. Now it's already been a well-known fact for a long time that more exhaust duration creates more power above 3,500 RPMs. It also keeps horsepower from dropping off after peak, which is useless in most applications. Now all the while, this is typically reducing power below 3,500 RPMs. Now we'll go further into the effects of exhaust duration some other time. But this is not the proper way to select lobe separation angle or build proper horsepower that comes with the proper fat torque curve to match the power curve according to the cubic inches, whether it be low RPM, mid, high RPM. A good solid fat power curve will always prove to be an engine that is near optimal or optimal, which is indicated by the power production in relation to the torque production per cubic inch. Now the Mr. T theory is full of holes and extremely incomplete. It can't even come close to the engine optimization or even satisfactory as far as I'm concerned. If it was any product I was putting my name on, you could bet your ass that I'd be putting out the best product I absolutely could, and I'd be positive it was going to give you the best and most complete power curve available and maintain the ability to idle fairly smooth also. Now BT's theory is an incorrect way to try to properly build a high performance engine, even if it's an LS engine. Now as I had said, it's a proven fact that more exhaust duration will produce more top end horsepower. But is this the end all be all, single best way to make a camshaft that'll produce more power, as Mr. BT says? Mr. T says you need to give an engine what it wants. Now I'm a 100% firm believer in giving an engine what it wants, but referring to a wide lobe separation angle and more exhaust duration as what an engine wants is definitely not the answer, even if it works to increase top end horsepower. Now why would Mr. T use exhaust duration as the primary technique for designing camshafts when it increases just upper RPM horsepower, even with the Ruck Oris cam? Now with the base of this theory being that LSA is adjustable and just a derivative and not an input, is this correct? Now Mr. Physics, Mr. DYNO, Mr. Bisart and I would say no. This is just another crude, incomplete attempt by a cam company to try to generalize all engines and valve events with practices that produce subpar performance products that are created with theories and formulas that are incorrect and incomplete for proper production of horsepower, torque, and optimal engine performance for any given application. Now Mr. T may be onto something if your goal is to produce subpar performance off-the-shelf camshafts that stand out in an industry full of subpar, incorrect off-the-shelf camshafts that are typically intended to replace camshafts in a stock engine and provide a power increase in a stock engine with the primary goal being an outcome. An engine that makes a little more power, idles nice and civilized. Now as I said, Mr. T's method might produce results, but the results are questionable. And with the right knowledge, T's theory could definitely be a lot better, especially if T wasn't so sure that he had it all figured out. And had he expanded his mind to a different thought process, his research may have taken him in the right direction. Now had his research taken him in the right direction, he may be able to spec and create proper camshafts that produce more complete power curve for any specific application and combination. Instead, Mr. T proceeds to use simple, incomplete formulas. Now T can't be spending much time on valve event timing research, and that's very apparent that there's no focus on optimal valve event timing research. Now I'm pretty sure T places most of his primary focus on research to create effective cam lobes. Now I will give T credit for his cam lobe technology, because I'm no mathematician by no means, but I've dabbled in the study of the polynomials and coefficients of cam lobe design, and it's pretty complex, taking into account all the things like area under the curve, ramp rates, lobe acceleration rates, intake opening and closing rates and velocity, exhaust opening and closing rates and velocity, deflection rates, etc. Now the polynomials of camshaft design take a lot of knowledge and consideration to take all the constants and variables to achieve and maintain a proper balance of the sine wave of kinetic and potential energy. Now the idea is controlling both kinetic and dynamic energy to produce and achieve the best balance of dynamic to static motion possible. Now this requires a spintron, and it takes a lot of money and knowledge. Now I'll definitely give credit to BT on his lobe design, like I said, because lobe design takes a lot of understanding in itself. But unfortunately, that's not all there is to it. To create the proper camshaft, you will still have to select the proper valve event timing. Now, just because I gave T a compliment on his lobe design, don't mean I think he can produce an optimal or near optimal camshaft. All the lobe research and design in the world won't make a difference if you don't pair it with the proper valve events. Knowing how to utilize LSA properly to achieve the proper valve events that any given specific V8 engine combination requires or desires will always produce a better, more complete power curve, and that's a fact. So now that I've broken down BT's theory that LSA means nothing and that it's just a derivative, I'm about to disprove BT's theory and prove what I'm saying is 100% correct and absolutely not BS. So now, for those of you who are still watching, you might be wondering, well, when are we going to get to the 108 LSA? Well, we're going to get to that right now. So remember what I said about the 112 and the 120 and the 108 LSA. They should make power at the same or lower RPM, but it didn't. Now, even as small as the RPM and horsepower increase was up top, this can still only mean one thing. And this is a prime example and a confirmation that the proper lobe separation angle has more of an effect and is more deep and complex than most people, even the supposed professionals in the camshaft industry, can comprehend. Now, I'm going to give the reason why the 108 LSA made more power at a higher RPM and held power longer than the 112 and the 120, which is not typical. So this information I'm about to give you guys, you won't hear another explanation like this on the internet but from me. Believe me, I've looked. So the 108 LSA peaked at 6,300 RPMs instead of 6,200 RPMs for the 112 and the 120, which, like I said, is not typical for the random change in LSA. Now, the change to the 108 LSA, being as it's still not optimal LSA for said engine, because the power gains up top and across the curve aren't as big as they otherwise would have been had the right LSA been installed for the specific combination. Now, I'm going to keep this as simple as possible, and once again, you will not hear this anywhere else on the internet. So out of the 3 lobe separation angles, the reason why the 108 had the best results is because the 108 provided more overlap, opened the intake valve sooner, and was closer to the ideal lobe separation angle, which equates to the proper valve events, which had allowed the 402 LS to better utilize the cylinder head. Now, even though that cylinder head was a ported CNC aftermarket cylinder head, it probably still didn't flow enough, especially at low to mid lift flow for the 402 LS. Now, opening the intake valve earlier allowed the flow to be presented to the cylinder earlier because of the better valve events more suited for the cubic inches and cylinder head flow characteristics. Now, this in turn allowed the cylinders to fill more efficiently and allowed the 402 LS to evacuate the cylinders more completely, which resulted in more clean charge being pulled into the cylinder, allowing it to breathe all the way to the higher RPM due to the overlap. Now, being as the 108 LSA had allowed the cylinder head to present more flow to the cylinder, because of the better combination of valve events, more suited for the cubic inches, the cylinder head flow, and a lot of other aspects of the engine, which means the proper LSA leads to the proper valve event timing, which leads to better power production. Now, it looks like Mr. T's theory is falling apart more and more the further we go. Now, as I said, you won't find another explanation like this on the whole internet of why the tight LSA worked better than the wide LSA, with a physical example and an explanation. Now, with that test engine being 402 cubic inches, I'm going to show y'all that the 128 formula works for LS engines. Now, I'm going to make a little prediction from my experience and what the dyno curves show and how they're closing in on each other, that the ideal LSA would probably be about 106. All right, let's see what the formula says. So we'll do 128 minus 402 divided by 8 divided by 2.165, because that was the valve diameter in those cylinder heads, times 0.91, and that gives us the 106. Now tell me what that dyno sheet shows. How are those dyno lines closing in on each other? Now, what do you think the ideal LSA would be? This 402 cubic inch LS engine would have made the best horsepower and torque and a better power curve with the 106 LSA. Now this was calculated by me in the 128 formula without depending on any flow calculations or multiple other factors of the engine, and was proven by the dyno sheet. Now all these results I've accumulated aren't falling in favor of Mr. T's incomplete camshaft theory that LSA means absolutely nothing. And it should be extremely evident, and you should clearly see that LSA definitely has a lot of an effect and is absolutely the key ingredient as a starting point for valve event timing optimization. And at this point you should really start believe what I'm saying. Now someday you may find that when everything has been selected for a specific high output combination has been optimally selected, but the only thing that is wrong is the camshaft has not been ground on the optimal LSA. Now even if the LSA is only off, say 4 to 6 degrees from the 104 LSA it should have been ground on, let's say it was ground on a 108 or a 110. Now not having that 104 LSA for an optimal combination that was absolutely optimal specifically with a 104 LSA camshaft. Now even though that may only seem like a few degrees, that 4 to 6 degree increase in LSA from the combination's optimal desired 104 LSA will literally in some circumstances cost you up to 25 to 35 plus horsepower across the entire curve. An incorrect LSA that is too wide will also cost you that fat power curve that comes with the optimal valve event timing. You will not get that 25 to 35 plus horsepower increase across the board from 4 to 6 degrees of exhaust duration. And that is Mr. T's incomplete answer to increasing power across the board. So at this point, does the evidence I have provided, or with the evidence I have provided, does anybody watching at this point think LSA really doesn't matter, as Mr. BT says? Or are Mr. Physics, Mr. Dyno, and I full of doo-doo? Many cam companies talk about LSA as if it's an adjustable feature. They usually spec a wide LSA for street use to crutch too much duration that many individuals insist on running, and for idle quality, they will usually only spec a narrow LSA for race use. Now the cam company's justification for a wide LSA is always better idle quality. But the truth of the matter, LSA is the principal parameter for the optimization of an engine within a specific power band for a specific engine, and it's not adjustable because there's only one optimal LSA for a specific engine combination, and only one specific LSA will produce optimal torque and power in any given engine for a specific power band. Now if a cam company ever gives you the suggestion to widen the LSA to improve idle quality, it's typically because the camshaft being chosen has too much duration. Sure, the wider LSA will spread the power band and improve idle quality, but the price you pay for spreading your LSA like Mike Honcho to achieve the better idle quality is a big decrease in power and torque, and ultimately it is wrong. Now here's a piece of info that usually don't make it outside of the camshaft industry. Cam grinders often purposely grind cams on a wide LSA to protect overzealous people from the negative effects of excessively long duration camshafts they insist on using. Now although LSA is the primary entity in camshaft selection and determination, it is still not enough for the optimally spec'd camshaft to be produced. LSA is more part of the answer and not the question. Now keep in mind how I constantly preach about the effect of valve event timing. Now another parameter on which to base camshaft is overlap. Now precisely how much overlap an application needs is pretty complex and is dependent on intake and exhaust flow, compression ratio, and multiple other factors. Now overlap is relative to the characteristics during the overlap triangle in relation to the cubic inches of displacement of the cylinder. The amount of overlap that is required to meet an application's needs depends on the RPM and the displacement in relation to the flow characteristics of the head and the valves at low lift flow. Now keep in mind that low lift flow is where the intake and exhaust valves are open during the overlap period. Now obviously the more RPM an engine's going to spin, the more overlap is needed, but only up to a certain point. Now the larger the cubic inches, the more overlap is needed for any given RPM range. Now conversely, the greater the low lift flow of the cylinder heads, the faster the valve opening accelerates, the faster the low lift flow is presented to the cylinder during the valve curtain area exposure, especially on the intake side. The higher the port energy or the higher the compression, all these equate to less overlap needed for optimal results. Now anybody that tells you that LSA or low lift flow don't matter has their head up their ass, and they need to have their head removed from their ass and go and have it checked. And after they have it checked, they need to get out of the business and go find another occupation to profess. Or they could go join the Flat Earth community. I hear they're always looking for new members. Maybe that would be a good fit, being as their theories don't apply optimally to reality, more specifically the regulatory laws of relativity that control everything around us, otherwise known as physics. Now the next thing is, how do you fine-tune and determine the optimal LSA selection to make the best power and torque for any given RPM range for any specific application? Now my grandfather and dad had taught me how to select LSA, but we didn't use a formula like David Bisart. But all the same parameters, coefficients, and variables were all taken into account. Now the way I had learned lines up very closely with the results of Mr. Bisart's formula. This is how I absolutely knew that David Bisart's formula had to be correct. It was way too much of a coincidence that two different ways come up with the exact same results, basically. Now I'm going to give you a couple ways to fine-tune the LSA. So for any given cylinder head, as the cubic inch increases, the LSA will get tighter. As the cubic inch decreases, the LSA will get wider. As the compression goes up, the LSA will get wider, because the higher compression has a higher expansion ratio, which evacuates the cylinder head faster, and which allows for a wider LSA. Now as the compression goes up, or the compression goes down, LSA gets narrower. As low lift flow decreases, the LSA will get narrower. As low lift flow increases, LSA will get wider. The sooner low lift flow is presented to the cylinder, the LSA will get wider, or the LSA should become wider. The later low lift flow is presented to the cylinder head, the narrower the LSA needs to be. Now it gets deeper and deeper and deeper, but those are a few examples. Now high lift flow doesn't play as big as a role in proper LSA selection because it's not as influential on the overall selection of the proper LSA, but peak flow ultimately is still a small influential factor on the LSA selection. Now valve curtain area will also be an influential factor on whether or not the LSA needs to be narrower or wider based upon effective valve curtain area and discharge coefficients. Now we're going to go over a few ways to overcome the problems that come from a wide lobe separation angle camshaft. One of the aspects is you simply need a better, more effective, higher flowing cylinder head. This is why the LS engines and some of the newer style engines, like the Gen 3 Hemi, can make really good power with the wide lobe separation angle. The Hemi heads have better cross flow, which aids in the induction process and the discharge of exhaust gases, which in turn aids in cylinder filling and evacuation, which also in turn allows for the functional use of a wider lobe separation angle, especially when coupled with a higher compression ratio. Now when it comes to LS engines, they can in some cases benefit from a wider lobe separation angle. There's a way too common misconception that LS engines like a wider lobe separation angle, and I think I had disproved that earlier. But due to some of the LS engine's relatively small cubic inches to cylinder head flow ratios, compared to say a small block Chevy, the LS engines can in some cases, notice how I said in some cases, because that's very dependent on a lot of other factors, the main factor being the use of a good aftermarket head that produces a high discharge coefficient and a high compression ratio. These are some of the simplest influential factors. Now these are the kind of factors that allow the engine to better utilize a wider lobe separation angle than a small block Chevy. I wouldn't say an LS engine could use a wide LSA with stock heads, especially a 6-liter or even a 5.3, because the stock heads, in some cases, flow only as much as, or only a little more than a Vortec head, and in some cases just as much as a low-level small block Chevy aftermarket head. Of course, unless you get into a higher flow and stock head, like for example the LS3 heads. The more precise you want to be with your LSA calculations, the more complex it will be, and the more information it will require. But the better you will be able to try to optimize any given specific engine combination. Now, the more you can comprehend about this, the deeper your knowledge can become, and the closer and closer you can come to be precision. Now, I'm sure there's people out there that are probably watching this video that don't have any understanding of these concepts, but hopefully the semi-deep, rather broad range of knowledge I've just given, and all the examples and explanations I have given, and the dyno sheets, and the engine examples, and the fact that David Bisart's 128 formula absolutely works, and it's been proven with that dyno sheet, with it predicting the 106 LSA for the 402 cubic inch LS with the 2.165 intake valve. And I hope there's people out there that could understand who I was talking about and who Mr. T is. And if you want to buy a camshaft, don't buy it from Mr. T, go buy it from CompCams. It's still unbelievable to me that Mr. T is still regarded as one of the best camshaft manufacturers in the business, specifically for LS engines, even though his incomplete answer to the complex input that is LSA is just simply a derivative to him. The derivative of intake center line plus exhaust center line equals LSA, which is just the angular measurement of the lobe centers. Now, Mr. T's camshafts are lacking the ability to make higher peak torque and power, accompanied by a fat power and torque curve that could have otherwise been possible had the valve events been designed properly, which would have resulted in a camshaft that makes power beyond anything any bogus theory could ever dream of making, while still retaining a decent idle and drivability. Now, I guess the moral of the story here is don't always take what you see in the mainstream performance industry as gospel, because their research that didn't lead them in the right direction may end up leading you in the wrong direction, and may be taking you down the path of subpar, incomplete performance. And if your goal is to eventually become properly educated in the complex science that is proper engine combination development, engine modification, and you want to have the ability to produce optimal engine combinations that are capable of extremely impressive output and ability, beware of corporate marketing ploys and educate yourself as much as possible. Don't go on to become that ignorant individual that thinks they have everything figured out and then proceeds to spread the BS they believe is true. Because for one, nobody wants to be known as that guy. And for two, if there's an individual that's just picking up pieces of information here and there, all the while the individual doesn't fully understand the absolute complete complexities of what is going on. But the individual does a lot of reading or watches videos, so eventually they think they have it all figured out. Then they proceed to regurgitate whatever BS they may have read, or maybe they are the kind of individual that regurgitate whatever BS they'd heard somebody else say, or maybe they gobble up and regurgitate something that somebody else had previously ate up and regurgitated. Either way, this individual starts to form their own theory and goes on trying to advise others. But the individual has no physical experience, automotive achievements, and because the individual's theory hasn't been put into practice, at this point it's just speculation, without proof of concept. So at that point, the individual probably shouldn't be spreading whatever theory or information they may or may not be right. Most of the time it's the latter. Now, nobody's got it all figured out, because there's more and more to be learned every day if you look in the right place. You must become properly educated, because there's always a bunch of BS to sort through, and you must differentiate the BS and fact. Always test your knowledge against other theories, because you might find something that you've been missing in the equation. So keep an open mind that what you know may not always be right. Now, hopefully you took what I said into consideration, because truth be told, I wouldn't be putting this information out there for everyone to see if I didn't know it was absolutely 100% true and 100% works. Now remember, I had said in the beginning that I honestly never even intended to give anybody any of this information but my own children, which I don't have. I intended to only educate my children with this knowledge, being as if some of this knowledge I retain goes 3 generations deep, and I would have liked to have made it 4. This is why I wanted to keep this knowledge in the family, but being as my CRPS, or complex regional pain syndrome, is destroying my brain, and I'm losing my memory, having kids is off the table now. So now, as I said earlier, I had started this channel with the intention to share as much knowledge as I can with whoever wants to listen, learn to build proper horsepower or go faster, or just want to listen to what I have to say. If I didn't know for sure it would produce optimal or near optimal engine performance, I wouldn't be preaching the truth about the importance of the correct LSA and the effect of LSA and the proper valve event timing, and the fact that valve event timing has the biggest effect on engine performance. A prime example of this engine building gospel is my bog truck engine, that 383 from earlier. That engine was built with this knowledge of the proper LSA selection and the valve events. Now even all those cam specs in that engine line up exactly with David Bisart's formula, but they weren't selected with David Bisart's formula. That just gives you a little bit of inside peek at how close the information that I learned as a kid is to Mr. Bisart's formula. Now, as I said, that engine was built with the knowledge of proper lobe separation angle and the knowledge of proper valve event selection that is relative to about every aspect of that engine. Now remember that 402 LS from earlier, from the LSA comparison? Well, my 383 small block Chevy makes more power than that LS with its CNC ported aftermarket aluminum heads with the 2165 intake valves. The best power that 402 LS made was from that 108 LSA, and it made 572 horsepower at 6,300 RPMs and 544 pound-feet at 5,200 RPMs. That LS engine had 19 more cubic inches on my 383, plus it had CNC ported aftermarket heads with 2165 intake valves. My 383 was built with methods I described in this video. It wasn't built with Bisart's formula specifically. It was built with methods that I had learned growing up, as I said. But all the camshaft specs in that truck line up with both of those formulas I'd given you guys earlier. Now that truck was just stock iron, heavily ported and modified 186 camel hump heads with 202 valves. Now my 383 makes 580 horsepower at 6,500 RPMs. That's 1.51 horsepower per cubic inch versus the 402's 572 horsepower at 6,200 RPMs, which equates to 1.42 cubic inches or horsepower per cubic inches. And the 383 made 545 pound-feet at 5,200 RPMs, which equates to 1.42 pound-feet per cubic inch, which is in the top 1 to 2% of engine builders. And the 402 made 544 pound-feet at 5,200 RPMs, which equates to 1.35 pound-feet per cubic inch. That's about the top 10% of engine builders. Now, nobody can tell me these methods don't work, because even with 19 more cubic inches and being an LS engine, my 383 small block Chevy with stock iron heads makes more horsepower than that 402 LS with CNC ported heads, or 2.165 intake valves. Now, even though my 383 didn't make as much power as a 540 big block Chevy, it still dominated big blocks with 160 cubic inch larger than itself, and it was capable of being a 3-time champion over those big blocks. Now, if these methods don't work, I don't think that 383 would have been able to do that. The most recent engine I had built was back in 2021. I had built another 383. I had spec'd a custom ground comp cam on a 106 LSA. I'll go over the cam specs for that engine in another video. I'm making a video on that engine specifically. It has an Eagle crank and rods, flat top pistons, 10.2 to 1 compression. It's got a pair of fairly heavily ported dart iron Eagle heads that I had unshrouded the valves, smoothed and modified the chambers. I'd mildly ported and blasted the Edelbrock Performer RPM manifold. Now you might be thinking 10.2 to 1 compression with an iron head on pump gas. Yep, it actually runs on 89 and it will run on 87, but I prefer to keep it on 89. There are secrets to running more compression with an iron head. I may go over that in another video too. Now, I had built this engine strictly with torque in mind because it was going in a 6,000 pound dually. Now, even though it was built with torque in mind, it will still make that 6,000 pound dually run a 1328 quarter mile at 104 miles an hour. Now, needless to say, that little 383 gets that truck moving. It makes 470 horsepower at 56 to 5,800 RPMs, and it makes 500 foot-pounds to 36 to 4,000 RPMs, and the damn torque curve is like a tabletop. This engine will also allow me to take off in third gear from a standstill, and this truck will do over 100 miles an hour in third gear. And at 5,250 RPMs, where the torque and horsepower cross, it makes 450 horsepower and 450 pound-feet of torque. Now, as soon as you hit 5,000 RPMs in this truck, it almost feels like a small shot of nitrous. You can feel the horsepower take over from 5,000 or 5,200 RPMs to 6,000. The way I had ported the heads and manifold and the combination of valve events at that cross point, it really starts the supercharging effect, and it is very evident. Now, this 383 is making big block torque from a small block less than 400 cubic inches, and the camshaft, I guarantee it, is a lot smaller than 98% of the people would think. Building an engine strictly for high torque production in a small cubic inch package is quite the feat, and extracting as much horsepower possible with the parts that are used without affecting the target RPM for the torque production is definitely not an easy task. It is much, much easier to build an engine successfully with horsepower in mind. This engine was built with the exact methods I went over in this video. Everything I had went over in this video, I can say with all certainty, is the most successful way to properly select a camshaft by LSA, overlap, duration, and lift. This formula is absolutely the best way for anybody to go about building an engine and for finding a starting point for the proper lobe separation angle. Now, in this video, I have left you with David Bisart's LSA and duration formulas, which will give you the basic starting point to figure out your lobe separation angle. And then the other thing you will need to figure out is your overlap, obviously, as I said earlier. I'm going to give a quick rundown of the 128 formula real quick. So first, we need to calculate the LSA, obviously. Then second, you need to calculate your overlap to identify your RPM range for your power and torque. And then the easy way, as I showed earlier, to find a target overlap range, like I said, was to find a camshaft with the RPM range you want, figure out the overlap, and then calculate the duration in the overlap as I showed earlier in the video. Now, I hope that example I showed for the overlap didn't confuse anybody. Now, like I said, play around with that duration formula, and if you manipulate the formula as I said, you can get an idea about how much overlap you need for your given combination, and then you can go around and make your own little data points and get an idea of how much overlap will be required for multiple whatever applications. Just hone your skills. And if somebody can't figure that out, just let me know in the comment section and I'll help you out. I really hope this information I've given points you in the right direction or helps somebody have a very beginning of a better understanding of the extreme complexities of speccing and building optimal or near optimal, extremely impressive engine combinations. Or maybe this allows somebody to question what they know and potentially find a better way. I just want to help people and see them build better and more thought out engine combinations with proper camshafts that are actually ideal for the engine combination application. I actually cringe when I see people on the internet spend a bunch of money on an engine combination with nice parts just to be paired with the wrong cam, which equals unknowingly throwing a lot of power and torque away without even knowing it or even caring that they're making the bad decisions or just being completely oblivious to the negative effects of their bad decisions and what their bad decisions are having the effect on their overall performance of their vehicle. Now, I'm not sure how many people will actually watch this long, heavily tech-oriented video with a fairly broad range of information for people to learn, but for those of you who made it through this whole thing, thank you. And if you watched every second of this, you might have something going on inside your brain, and I like that. We need more people like you in this world. Now, depending on how this video does, this may be my first video in a series of camshaft selection and engine optimization videos. So if you like this video, hit the like button, shoot me a comment, and tell me what you liked about the video. And tell me if you would be interested in me doing more videos about this kind of stuff. Now be sure to subscribe, like, share, and hit that notification bell. And if you haven't subscribed to David Bisart's new channel, please do so. Mr. Bisart has been forced by YouTube to start another YouTube channel. He has lost 27,000 some odd subscribers. His new channel is just called plain David Bisart, and that's the one you're going to want to sub to. His old channel is called David Bisart Performance. So help my friend David Bisart out with a sub to his new channel. David deserves every sub for many reasons, but just based on the simple fact that he's giving out info that you would normally have to pay for, I'd say giving him a sub, which is free, is a pretty damn good deal. Now with all this being said, for those of you who don't know, I'm Adam, this is Cattle Dog Garage. Thank you everybody for watching. Remember, like, share, subscribe, notify. I'll see y'all next time.
If you test these 4 camshafts back to back on the dyno like we have, you'll find that as you add this exhaust valve open point to the camshaft, the engine makes more power from 3500 on up. So it's very important to not design a cam based on LSA. It's important to design a cam based on what the engine tells you it likes. So lobe separation angle is a derivative of getting the open and close points where they need to be. The other thing about LSA is we do not allow you to randomly change LSA because we don't want camshafts out there with improper valve events. So my bit of advice today is don't focus on LSA.